After labeling the three test tubes as alkanes, alkenes, and aromatics, add 4 drops of each in their respective test tubes. Add equal amounts of distilled water and gently swirl. This is the test for water solubility. The water is colored red so as to help to visualize or in distinguishing any layers which may form. Water is a polar solvent, and we would be looking for separation. If there is a separation in layers, which layer is on the top, whether it's an organic layer or the water layer. This will depend upon the density of the sample. You can clearly observe that the colorless or the transparent color layer is on the top and the red color is below, indicating that the sample seems to be insoluble in water. If separation occurs, increase the amount of water and gently swirl again to confirm the insolubility properties. You will notice the transparent colorless layer of the organic solvent on the top, indicating it to be water insoluble. Repeat this test using ligurine in place of water. We would add 4 drops of each sample: alkane, alkene, and aromatics. The alkane is hexane, the alkene is cyclohexene, and the aromatic is toluene. We will add 4 drops of ligurine to each of the test tube. No separation is observed, hence soluble. Unfortunately, in test tube 2, I had noticed a color, and hence I'm going to repeat that specific test for cyclohexene, test tube number 2. So I'm going to add 4 drops of cyclohexene and equal amounts of ligurine. Doesn't seem to be a layer separating, and hence this compound is also soluble in ligurine, which is a non-polar. In the flame test, we ignite the flame carefully by adjusting the gas lever and adjusting the flame so that you get a clean blue color flame. Decrease the flame size. Using a metal spatula, add 2 drops of hexane or the alkane Observe the color of the flame, the time in which it burns, whether you see a dark smoke coming out. This burnt in about 4 seconds, was a yellow flame, not very sooty because we did not see any carbon. In the cyclohexene, 2 drops of the sample is taken onto the spatula and we ignite it. In this particular case, you can see it's yellow flame. It's burning with a black smoke, and it's about 10 seconds. There was no unburned carbon seen floating. In the aromatic, which is toluene, you're going to take 2 drops of sample and you will observe that the yellow color flame burns. It's seen with a thicker black smoke, unburned carbon particles floating around. Classic of a aromatic compound being present. Chemical testing. Label the 3 test tubes 1, 2 and 3 corresponding to hexane or alkane, cyclohexene 2 or alkene, and number 3 is the toluene, which is an aromatic. Add 4 drops of the sample to each test tube, to the corresponding test tubes. Add 1 drop of alkaline KMnO4 to each test tube. Observe your color of the toluene. It showed number 3 and it is pink. Observe this color. You can see that there is a brown precipitate, typically of manganese dioxide, which gets precipitated when there is a double bond. And in test tube number 1, which is an alkane, no change at all. So the pink color of the KMnO4 remains, except it changes for test tube 2, which is an alkene, and it is classical whenever there is a double bond, it will react. Label 3 test tubes 1, 2 and 3 in the same alkane, alkene and aromatic. This is what is called as a sulfuric acid test. Sulfuric acid is an electrophile and it will react only with alkenes. That means test tube 2. It will confirm an alkene. You have to carefully add sulfuric acid, and this is done in a fume hood. This is concentrated sulfuric acid. So we've placed 5 drops of each sample in the respective test tubes, and now you're going to add the concentrated sulfuric acid. Observe for any color change. You will see that the cyclohexene has reacted, and you can see that it is an alkyl sulfonic acid which has formed, and so you get a brown color. Wherever there is a double bond, the sulfuric acid has reacted at that particular site. There was no change in color in the test tube 3, which is toluene. Neither was there for this one, which is test tube 1, which is an alkane. Observe test tube 2. You can see the color, typically brownish for an alkyl sulfonic acid. So we've identified cyclohexene. Now we're going to add nitric acid to test tubes 1 and 3. This is concentrated nitric acid, and you will add 1 drop only. Shake, and then if necessary add the second drop. There is no change observed for the hexane. We're going to add another drop of concentrated nitric acid. No change observed. So hexane primarily does not react to this toluene, which is aromatic. We had already earlier added sulfuric acid concentrated, and now we are adding 1 drop of nitric acid, concentrated nitric acid. You have to be careful when adding nitric acid to toluene, and you can see that an ortho and para-nitrotoluene will form. This will be seen as a pale yellow color precipitate. Do not heat this, and neither you should add more than 3 drops of concentrated nitric acid. The pale yellow is typically an ortho and para-nitrotoluene. This way you have identified again chemically the classification of an aromatic compound. Let's take a single recap. The 3 samples with water, the liquid on top indicates water insolubility. And then we did what is called as the ligurine test, and we noticed that it was all soluble in ligurine. Then we did the flame test, and we seen the different types of flames, and we were clearly able to identify the aromatic compound toluene. Hexane burnt with the least yellow and least sooty flame. In the chemical reactions, we noticed that the alkene reacted with the KMnO4 to form manganese dioxide. The test tube alkane and the aromatic never changed their color. It retained the pink color. Finally, we did the confirmation test with sulfuric acid and noticed that the alkene did react clearly to form the alkyl sulfonic acid. Test tube 1 and test tube 3 remained colorless. To test tube 3, then we added nitric acid, and in that one it did change and formed a pale yellow precipitate at the top, indicating that to be a aromatic compound. In this way, we have classified the the compounds alkane, alkenes, and aromatics. Thank you.